All right, there's a couple things that are going to be changing for this video. My background, for one, I don't have that great of lighting, and my microphone is not with me at the moment. So there's a lot of stuff. So just don't look at me and just pay attention to the lesson at hand. Today, we're going to be combining the previous two sections. We started off first with trig functions, and then we went to angles and how to use that with the initial side and the terminal side, and some interesting properties of that. Now we're combining those two into one lesson. Now, you may look at this and see that you see sine, cosine, tangent, and their reciprocal functions right there. And you might notice it doesn't say opposite, adjacent, and hypotenuse on it. And you might be wondering, where do these values come from? Well, that's what I actually want to talk about right now. All right, so to start off, we can see an angle right over here. We can see the initial side right here and the terminal side here. Now, believe it or not, this actually makes a triangle. Where does this make a triangle? Right here. Now, in this lesson, what we're going to be doing is that we're going to be taking wherever the terminal side is, and we're going to be drawing a line from the terminal side down to the x-axis. And the angle that we're going to be considering is going to be this one right over here, whatever the angle is between the terminal side and the x-axis. Now, when we do that, that is going to be our theta angle. Well, how does this help us? If we're going to be using trig functions on this, we need to label our triangle. So for instance, if this is our theta, I can draw an arrow all the way across the triangle. So this is going to be our opposite side. This is going to be our adjacent side. And this is going to be our hypotenuse. And we've seen this in 9.1, so we're very familiar with how all of this works. But I am going to relabel them. Let's look at our adjacent side. What can also be represented by this adjacent side? Well, instead of saying adjacent, that lies on the x-axis. So I'm going to say x. Instead of saying adjacent, we're going to say x. Now, what about that opposite side? Well, the adjacent is running along the x-axis. The opposite side is going up and down, which that sounds like the y-axis to me. So we're going to say y over there. Now, what is the hypotenuse going to be? Well, the hypotenuse is that line. It is our terminal side. Now, in our previous 9.2 lesson, we learned that that is going to be the radius if we have a circular object. So this is going to be r. We're going to say r instead of hypotenuse. Now, if we use that with our sine, cosine, and tangent, what does that do to our trig function? Now, the first thing that we're going to have to do is use our SOHCAHTOA. Sine being opposite over hypotenuse, cosine being adjacent over hypotenuse, and tangent being opposite over adjacent. And that's how we're used to seeing it right here. But now that we have other values, let's see if we can fill them in. Instead of saying opposite, we are going to put y. And instead of saying hypotenuse, we will put r instead. So now we have y over r. Now we're going to replace adjacent and hypotenuse as well. Adjacent is going to be our x value. Our hypotenuse is going to be our r value. Opposite for tangent is going to be y, and adjacent is going to be x. This is what we're going to use now. Now our cosecant, secant, and cotangent is going to be the same. Remember, those are just the reciprocal versions of the things that we had before. So we're going to fill those in rather quickly. R over y, r over x, and x over y. Now this will be true no matter where our terminal side is going to be. And I want to show you that. Now, if you look at this angle, how is this different? Well, we still have a triangle. If you notice, we have our terminal side being in this other quadrant over here. Well, how does this change? We still want to make a line that goes from the terminal side down to the x-axis, and that will be our triangle. Our theta angle is still going to be this angle right over here. Notice what has not changed. Being that we're able to draw an arrow going across the triangle to this one, this is still going to be our opposite side. And this will still be our adjacent side, and this will still be our hypotenuse side. Let's see if any of our markings has changed. Well, our adjacent side is still on the x-axis, so we'll still call that x. Our opposite side is still going up and down, so we're going to call that y, and our hypotenuse is still the radius. So no matter where you draw your terminal side, the values for the opposite, adjacent, and hypotenuse will always be x, y, and r, respectively. All right, we are finally back to our example one, and now you can see where all this comes from. Our sine being y over r, and our cosine of theta being x over r. Our tangent of theta being y over x, and the reciprocal functions being the actual reciprocals of it. And it all makes sense now. Now there is a bit of Pythagoras right in the middle, but that just comes from our a squared plus b squared equaling c squared. But instead of saying a, b, and c, we're saying x, y, and r. And we just solved it out for r because r is our hypotenuse. It is our c. So that's where that thing comes from right there. Now, we are going to use our newfound trig functions on example one and see if we can figure it out. Now, here we have step one and step two. Our first step would be to figure out what our x, y, and r is, because I would say that is pretty important to figuring this out. Now, here it says step one, and our step one is going to be figuring out what our x, y, and r is. And once we figure those things out, then we can just drop them into our equation. If you notice, we have our x and y already. If we look at our example problem right over here, we have our x and we have our y. So I'm just going to label it x equals -3 and our y equals -4. What is our r going to equal? Well, our r is going to equal that function that we set up there. That's going to be r equals the square root of x squared plus y squared. So let's just plug all of those values in. R equals the square root of -3 squared plus -4 squared. And that's something we can just plug into Desmos. Again, to use our square root, all we're going to do is use this keyboard that they provided, and we have a nice little square root function here. Make sure that the -3 is inside of parentheses, and then you say to the power of 2. You will add it to -4 and make sure that is in parentheses to the power of 2. And we get 5. So here we're going to say our r equals 5. Now that we have our value for r, we can just plug them into all of the trig functions. All I did was copy it down from our previous example, sine of theta, y over r, cosine of theta, x over r. We've talked about this already. Now we're just going to fill all of it in. So our y over r is just going to be -4 over 5. Our x over r will be -3 over 5. Our y over x will be -4 over -3, which will be +4 over +3 because I have a negative on the top and the bottom, so they cancel out. Same thing with the other side. I'm going to say 5 over -4. Now you could just say -5 over 4. That's completely fine. R over x will be -5 over 3 because I just flipped it over on itself. And then my x over y will be -3 over -4, which then will equal 3 over 4. And we are done with all of our trig functions. So remember, step one, find out x, y, and r first, and then you can just throw it into your trig function. All right, so let's give our guided practice a shot. Now, this is the point that you should pause the video and try it out for yourself. Our step number one will be to try and find out the value of what our x, y, and r equal. Now our x and y are very easy. That's going to be -6 and 2. Where did I get those values? That's right here, x and y. Now the r is a little bit more involved, but it's not too bad because we have a fancy little function for that already. That will be the square root of x squared plus y squared. So that's going to be r equals the square root of -6 squared plus 2 squared. Throwing it into our Desmos, we see that we have a weird decimal thing. So we're going to have to solve this a little out by hand, which is okay. Don't get too afraid of it. We have done this before in mathematics. So we're going to say 36 plus 4. So 36 is -6 squared, and 4 is 2 squared. So this will be the square root of 40. Now we're going to take the prime factors of 40 and put that under the square root instead, and this will be 5 times 2 to the power of 3, or 5 times 2 times 2 times 2. And then that will equal 5 times 2 times 2 squared. And that means that we could go ahead and take that nice little 2 squared out. So our final answer is going to be r equals 2 square root of 10. If you don't know what I did there, please go ahead and look up a video on how to simplify a radical. So our r is going to be 2 square root of 10. Now we can go ahead and drop them into our trig functions. So here we first have our sine, cosine, and tangent. Y is going to be 2. Our r will be 2 square roots of 10. X is going to be -6. R again is going to be 2 square roots of 10. Y is going to be 2. X is going to be -6. Now you will have to do a couple steps to this. First, you'll have to simplify and then you'll have to rationalize. Here's a pro tip. I want you to simplify first and then write out the other 3 trig functions and then rationalize everything that you. There's a 2 on top, 2 on the bottom, so this will just be 1 square root of 10. This will be -3 over square root of 10. This will be -1 over 3. Now that everything is simplified, I want you to write out our other 3 trig functions. The first one is going to be square root of 10 over 1. You could also just say square root of 10 because over 1 is just going to be by itself. This next one will be negative square root of 10 over 3. The negative can go on the top or the bottom. It doesn't really matter. And then this last one is just going to be -3. Again, because it's over 1, it doesn't matter. Now what we want to do is we want to rationalize everything that we can. Everything on the right is already rationalized. However, the things on the left is not quite yet rationalized. If we remember, we're going to multiply the top and bottom by square root of 10, which will make this square root of 10 over 10. We're going to do the same thing with this one, which this will make -3 square root of 10 over 10. And the last one does not need to be rationalized. Everything was kind of bleeding into each other, so I moved everything over a little bit, and these are our final answers. Our sine of theta, square root of 10 over 10. Cosine of theta will be -3 square root of 10 over 10. Tangent of theta is going to be -1/3, and our cosecant, secant, and cotangents are just going to be the reciprocals of all of those. If you notice, the hardest part about all of this are the things that we went over earlier in the year. So the 2 things to look up if you were confused is rationalizing denominators and simplifying radicals. Get good at those 2 things because those were the hardest part about this entire lesson.